So today we are going to study the chapter 1 solution part 2. So that is we are going to study here expressing the concentration of the solution. The topics covered are mass percentage, volume percentage, mass by volume percentage, parts per millennium, mole fraction, molarity, molality, and simplified formula and quick tricks. So expressing the concentration of the solution. Composition of a solution can be described by expressing its concentration. So how we can describe a composition, what is there in the solution? That is by expressing its concentration. Concentration can be expressed either qualitatively, quantitative. So by looking the quality or quantity, we can know the concentration, right? For example, qualitatively means we can say that the solution is dilute. Relatively, that is dilute means what? That is a solute amount is relatively small, right? But concentration means relatively very large quantity of solute. So in the image we can see. So dilute means what? There is less solute, whereas the concentration, the solute quantity is more. But in real life, these kinds of description can add to a lot of confusion, and thus the need for a quantitative description of the solution is required, right? So this is the by seeing we can't say whether it is qualitative or dilute or concentrated, right? So we have to know, we need some measurement to describe this quantitative concentration. There are several ways by which we can describe the concentration of the solution quantitatively. So we are talking about the quantity, means amount, right? So first is the mass percentage. And what is the, how we can write W by W? Mass percentage is W by W. The mass percentage of a component of a solution, that is a W by W, is mass of the component in the solution by total mass of the solution into 100. So first we have to get the mass of the component in the solution. Then by divided by total mass, the total mass of the solution, then into 100. For example, if a solution is described by 10% glucose in water by mass. So what is the mass of the glucose? 10% of glucose in water by mass. So what it means? 10 gram of glucose and dissolved in 90 gram of water. So the total is 100 gram solution. So to make the 100 gram solution, 10% is glucose and the 90% is water. So that is the 10% glucose in water by mass means 10 gram glucose plus 90 gram water equal to 100 gram solution. So 10% glucose in water by mass means 10 gram glucose plus 90 gram water making 100 gram glucose solution. Concentration described by mass percentage is commonly used in industrial chemical applications. So where we make use of this principle mainly in the industrial chemical application. For example, commercial bleaching solution. So commercial bleaching solution means 3.62 sodium hypochlorite. So rest is what? Water. So if we take a 100 gram solution, we have 3.62 gram of the sodium hypochlorite and the rest 96.38 gram is water. So usually the concentration described by mass percentage is used in the industrial chemical application. Commercial bleaching solution is equal to 3.62 mass percentage of sodium hypochlorite in water. The next is volume percentage. It is represented by V by V. Volume percentage of a component, that is V by V, equal to volume of the component by total volume of the solution into 100. Almost similar by mass percentage, but the term here it is volume. For example, 10% ethanol solution in water means what? Here it is volume. So that will be in liter or ml. So usually we use the ml for small measurement. So here that is 10 ml ethanol dissolved in how much water? Dissolved in 90 ml water. Total volume is 100 ml. Okay, so 10% ethanol solution in water means 10 ml ethanol plus 90 ml water gives the 100 ml. So 10% ethanol solution in water equal to 10 ml of ethanol dissolved in water, making how much water? 90 ml water, making total volume as 100 ml. Solutions contained in liquids are commonly expressed in volume percentage. So the we are using this volume percentage mainly in case of the solution containing liquids. For example, a 35% of solution of the ethylene glycol. What is an ethylene glycol? It is an antifreeze. Antifreeze means what? It is used in the cars for cooling the engine. So antifreeze is used in the cars for cooling the engine. So a 35% solution. At this concentration, the antifreeze lowers the freezing point of water to 255 to 55.4 K. That is a minus 17.6 degrees Celsius. So if we use 35% ethylene glycol mixed with water, the ethylene glycol lowers the freezing point of the water, so it cools the engine of the car. So that's why we are using 35% of the ethylene glycol as the antifreeze. Clear? Mass by volume percentage. Next is mass by volume percentage. So mass W, volume V. W by V. Another unit which is commonly used in medicine and pharmacy is mass by volume percentage. So where we are using this mass by volume percentage, it is medicine and pharmacy. And what is the equation here? Mass of the solute dissolved in 100 ml of the solution. So mass, how much solute is dissolved in 100 ml solution? So that is the equation. Mass of the solute dissolved in 100 ml of the solution. Next is parts per millennium, ppm. When a solute is present in trace quantity, it is convenient to express concentration in parts per million. So when the solute is only in trace quantity, we studied in the last class about the fluoride and all. Fluoride in the paste, toothpaste, it is represented in ppm because it is present in the trace amount. So if the solute is present in trace amount, we can express the concentration in ppm, parts per million. So how we can find number of the parts of the component? By total number of parts of all component of the solution into 10 raised to 6. So that is in million. So that is a 10 raised to 6. So number of parts of the component by total number into 10 raised to 6. As in the case of the percentage, the concentration in parts per millennium can also be expressed as mass to mass, volume to volume, mass to volume. So in all these cases also we can use the ppm. Now, a liter of seawater, that is a liter of seawater, it is in grams if it is 1030 gram. It contains 6 into 10 raised to minus 3 gram of dissolved oxygen. So, if we take the amount of the dissolved oxygen in a liter of seawater, it is about 6 into 10 raised to minus 3. So that means it is minus 3. So such a small concentration is also expressed as 5.8 gram per 10 raised to 6. That is 5.8 ppm of seawater. Okay, so that means the dissolved oxygen is in very trace amount. So we can express it in which one? We express it in ppm, and that is 5.8 ppm in 1 liter seawater. Concentration of pollutants in water or atmosphere is often expressed in terms of microgram. So this is the microgram or ml minus 1 or ppm. So the pollutants in water or atmosphere that can be expressed in ppm or microliter. Next is mole fraction X. Commonly used symbol for mole fraction is X, and subscript used on the right hand side of the X denote the component. So in the right hand side we can see a now alpha, a subscript, that is an alphabet. So that is the component. So here what is the mole fraction equation? It is number of moles of the component by total number of moles of component. Number of moles by total number of moles. Now for example, in a binary mixture, so we told in this chapter we are usually studying binary mixture only, that is it involves only two components, right? So if the number of moles of A and B are Na and Nb, so number of moles of A is Na, number of moles of B is Nb. So how we can write the mole fraction? So we are finding Xa. So what I told, the alpha, that is the alphabet near the in the right hand side of the X denotes the component, right? So here we are finding the mole fraction of A. So X is the mole fraction, A is the component. So in a solution with A and B, we are going to find the mole fraction of the component A. How we can find the moles of A by total number of moles, right? So here we can write total moles is total number of moles of A is Na, and by the total number of moles in A and B is Na plus Nb. So that gives the mole fraction of A. So what about the mole fraction of B? Mole fraction of B, Xb equal to Nb by Na plus Nb. For a solution containing I number of components. So if it is infinity, what we have to do? First we have to report Ni, right? Then N1, N2 up to Ni we have to add. So we can see Ni by sigma Ni. That is simple expression. It can be shown that in a given solution, sum of all the mole fraction is unity. So if we add all the mole fractions in a solution, if we add the mole fractions, if we add the mole fraction of all the components in the solutions, if the sum of all the mole fraction in a solution, we can see the sum is equal to unity or 1. That is also important. And mole fraction unit is very useful in relating some physical property of solution. For example, vapor pressure with the concentration of the solution. Quite useful in describing the calculation involving gas mixture. So usually mole fraction is used in the physical property. For example, the calculation involving gas mixture or vapor pressure and all, we use the mole fraction unit. Now an example, calculate the mole fraction of the ethylene glycol in a solution containing 20 gram of C2H6O2 by mass. So how much is the ethylene glycol? It is 20 gram by mass. So what is the question here? It is a mole fraction. So assume that we have 100 grams. So usually we assume that we have 100 gram, and out of the 100 gram we have the 20 gram ethylene glycol. So rest 80 gram is water. So if we consider the molar mass, C, carbon is 12, hydrogen is 1, oxygen is 60. So molar mass of C2H6O2 is C2, 12 into 2 plus 1 into 6, that is hydrogen, and oxygen 16 into 2. So that is a 24 plus 6 plus 32, and 62 gram per mole is the total molar mass of ethylene glycol. Okay, 62. So how we find moles? Mass by molar mass. So moles, first we have to find the Na, moles, right? So for finding the moles, we have to calculate the mass by molar mass. And what is the mass here? Mass is 20 gram, ethylene glycol 20. And molar mass we told it is 62. Here we found it is 62. So mass by molar mass 20 by 62. So that is the 0.322 mole. So what are the moles of the ethylene glycol in the solution? It is 0.322 mole. And in water, similarly, 80 by 18. How we got the 18 in H2O? We have to calculate like this, H2O. So H2O is 2H plus 1 oxygen, 80. So 80 gram by 18, that is 4.444 mole. So we got the moles of the ethylene glycol and the water. And next is the mole fraction. Right, so X glycol, ethylene glycol is equal to mole fraction, ethylene glycol is equal to A, compound A, Na by Na plus Nb. So what is Na? Na we found the mole is 0.322 and Na plus Nb is 0.322 plus 4.444. So the answer is 0.068. Okay, hope this is clear. Any doubt you can post in the comment, I will answer. Okay, so this is the mole fraction. So in case of the mole fraction, first we have to find the molar mass, and from that we are finding here which what here from the molar mass here we are finding the moles, number of moles. When we get the number of moles only, then we can go to the next step. That is a mole fraction require the number of moles. Okay. And what about the water? We found the mole fraction of the ethylene glycol, water. Water we can find by the similar way, that is a NB by Na plus NB, or we have studied in a given solution sum of all the mole fraction is unit, right? So here X, the mole fraction of ethylene glycol plus water will be equal to 1, right? So we know the ethylene glycol mole fraction. So we just subtract 1 minus, that is we can subtract this mole fraction of the ethylene glycol from 1. So 1 minus 0.068 is 0.932. So by both equation we get the answer. Now next is the molarity, capital M. So very important, because molarity is capital M, whereas the molality is small letter m. Molarity is defined as the number of moles of solute dissolved in 1 liter or 1 cubic decimeter of the solution. So what is molarity? The number of moles of the solute dissolved in 1 liter solution. That is the molarity. And what is the equation? Moles of the solute by volume of the solution in liter. Moles of solute by volume of the solution in liter. For example, 0.25 mole liter per liter minus 1. That is a 0.25 mole. Solution of, for example, 0.25 mole liter minus 1 is, or 0.25 molarity solution of NaOH. So this is the question. So what is the answer? This means 0.25 mole of NaOH has been dissolved in 1 liter. So 0.25 molality means 0.25 mole of NaOH is dissolved in 1 liter solution. So here, number of moles of solute. So here it is 0.25 mole. So number of moles of solute dissolved in 1 liter is the molality. Here it is 0.25 mole NaOH dissolved in the solution. 1 liter solution. Now calculate the molarity of the solution containing 5 gram of NaOH in 450 ml solution. So the molarity have to be calculated. And what is the amount? 5 gram NaOH is there, and the solution is 450 ml. So first we have to find the molar mass. So what is the molar mass? Na 23, O 16, hydrogen 1, and total 40. And what they have given, what is the information they have given? 5 gram of NaOH in 450 ml solution. First, again, we have to find the number of moles. So to get the number of moles, we have to get the mass by molar mass. So what is the mass of the sodium hydroxide in given in here? In this case, it is 5 gram. So 5 gram by total. That is a 40 gram. So 5 by 40, it is 0.125. So the number of moles is 0.125. Now next is convert the volume of solution from ml to liter. The question is in ml, but what we are finding, it is 1 liter solution, right? So we have to convert it into liter. How we can convert? Just 450 ml by 1000. 450 by 1000. Okay. So that is 450 by 1000. It gives the volume of the solution. Now the equation, molarity equal to moles of solute by volume of solution in liter. And so what is the moles of solute? It is 0.125. And what is the volume? 450 by 1000. So into here 450 by 1000, it comes reciprocal. So 1000 by 450. So the answer is 0.278. Molarity. 0.278 molarity is the answer. Now next is molality. It is small letter m. So we have to be very careful. Capital letter M as well as small letter m. Molality is defined as the number of moles of the solute per kilogram of the solvent. So only one difference, that is a kilogram. Molality is the number of moles of solute per kilogram of the solvent. Whereas the molarity is dissolved in 1 liter solution. This is solvent. Molality is in number of moles of the solute per kg of the solvent. So molality, small letter m is moles of solute by mass of the solvent in kg. Now, example, 1 mole kg minus 1. That is 1 molality. Means what? 1 molality of the KCl means 1 mole of the KCl is dissolved in 1 kg of water. 1 kg. So, the volume, that is the volume have changed. Right? Unit has changed. There it was ml. Sorry, there it was liter, but here it is kg. The unit of the measurement has changed. Each method of expressing the concentration of the solution has its own merits and demerits. Mass percentage, ppm, mole fraction, molality, all these are independent of temperature. So this is important. Which all are dependent on temperature? Mass percentage, ppm, mole fraction, molality. But molarity is not mass percent, ppm, mole fraction, molality are independent of temperature. They are not at all dependent on temperature. But molarity is a function of temperature. Very important. Molarity is dependent on temperature. Molarity is dependent on temperature. Whereas mass percent, ppm, mole fraction, molality, these are not at all dependent on temperature. Why? Because the volume depends on temperature. Mass does not. Volume depends on temperature. So we know this is based on the volume. So molarity is based on the volume, whereas the molality is the mass. Right? So molarity depends on temperature because volume depends on temperature. Now an example of molality. Calculate the molality of the 2.5 gram of ethanoic acid in 75 gram of benzene. Okay, so we have the 2.5 gram ethanoic acid and 75 gram of benzene. So first we are finding the molar mass C2H4O2. So how 12 into 2 plus 4 into 1, 1 into 4 plus 16 into 2. So total it is 60 gram per mole. 60 gram per mole. So that is a molar mass. And how much is ethanoic acid? 25 gram. Benzene 75 gram. So how we find the moles? Again, how we find 2.5 gram? The here equation we found now. Mass, moles equal to mass by molar mass. So number of moles we have to find first. So moles equal to 2.5 gram by total. That is a 60 gram. Here total molar mass is 60 gram. So 2.5 gram by 60. That is 0.0417 mole. And convert the mass of the benzene from gram to kilogram. We already studied that. How? Just put the 1000 below. 75 by 1000. And molality of the C2H4O2 is the moles by kg. Right? So moles we found it is 0.0417 and mass is 75 gram by 1000. So when we divide, it becomes a reciprocal. You know that, no? So 0.0417 into 1000 by 75 and the answer is 0.556 mole per kg. Clear? So this is how we find the molality. So we can just look what is the summary we have studied now. So first we studied the mass percentage. W by W, it is a mass percentage. It's the mass of the component in the solution by total mass of the solution into 100. In case of volume, we replace the mass by volume of the component by total volume of the solution into 100. Next is mass by volume percentage. It is mass of solute dissolved in 100 ml of the solution. Parts per million, number of parts of the component by total number of parts of all the components of the solution. Mole fraction X equal to number of moles of the component by total number of moles of all the component. And if it is, we have to find the mole fraction of a single component. What we do? Of a component, we do the same is the number of moles by total number Na plus Nb. Molarity, capital M is moles of solute by volume of the solution in liter. Molality, small letter m is moles of the solute by mass of the solvent in kg. So molarity, the capital molarity, it refers to volume. Small letter m refers to mass in kg. Now, concentration described by mass percentage. What are the use? Usually, mass percentage is used in industrial chemical application, whereas volume percentage solution containing liquids. Mass by volume percentage medicine pharmacy, and if it is in solute is in only trace quantity, we use the parts per million parts per million. Even we have used in trace quantity, that is a pollutants also. Pollutants in water, we use which one? Air pollution or water pollution. Also we use the ppm, that is when the solute is present in the trace quantity. Mole fraction unit is relating some physical property of solution, that is in case of the gaseous solution or the vapor pressure, etc. Molarity and molality is the number of moles of solute dissolved in 1 liter solution, whereas the molality is the number of moles of the solute per kg of the solvent. And sum of the mole fraction is unity. All the mole fraction in a solution will be, the sum will be unity. And mass percent, ppm, mole fraction, molality, they are not at all dependent on temperature, because mass is not dependent on temperature. But the molarity is a function of temperature because the volume depends on temperature. Thank you for watching my video. For any doubts, please don't forget to post in the comment section. Please like, share, subscribe my channel for more updates. Thank you.